Hello, this is Julian Arrington, and this is a brief video of how our bridge fared in load testing. So, our bridge broke to our bridge broke at the middle of our loading platform. Four beams ripped out of its glue socket and caused the failure of our bridge. This is kind of weird because in our trust analysis, it didn't account for this part of the bridge. It only accounted for the forces being weighed down on the trusses. So I wasn't really sure of how the middle broke and not the truss. Maybe because all the support was going to the middle. So technically, our bridge could be repaired if we wanted to. We would just have to replace the sticks in our loading platform. The trusses remain fully functional. Some of the issues we encountered while building this bridge, it was a very long and hard process. Most of it was due to timing. The glue of our bridge was drying for a long period of time, so it's not like we could make any progress in building the bridge. We really had to wait on all the things to dry. Another issue in our construction was the mass of our bridge. Originally, we had two trusses that weighed 6 grams. My apologies, 6 grams each, and this is a horrible mistake because when we weighed all of our pieces together, it was over 25 grams. So me and my partner Jackson had to make a change to this, and we had to cut down the truss of the bridge to make it smaller, to make it shorter, and to also include less rungs. And the final mass of our bridge came out to be 24 grams. Positioning of the bridge when we were gluing it, holding together all the pieces of our bridge was also very difficult. We didn't know if we wanted to use a clamp or a paper clip at times or a binder clip. It was kind of hard. We had to get really creative with how we held everything together. We started using, we definitely used clamps to hold everything together while we were building our bridge. Some advice I would give to the contestants next year is to prematurely know how you're going to glue your bridge together. That's a really important part of this, and if you don't know, you might be at a standstill for a long time. Also account for the weight of the glue. We also had problems with this in our building stages. We had to go back and take samples and determine how much the glue weighed, and we had to cut down on how we were gluing because it starts to add up a lot. Another piece of advice is to focus on your design. Sometimes people would be looking over and they would lose track of their own design and worry about what other people are doing. But if you're focused on your design, that's the only way you can make it better. It's good sometimes to ask people what's going right, what's going wrong, but when it comes to a point where you're not fully invested in your bridge and you're investing in somebody else's bridge, it's not going to come out to its maximum potential. That's what I suggest that you do. Focus on your bridge and understand that it's trial and error with these things sometimes, and that's okay too. Don't get too frustrated or give up or just scratch everything. Just make adjustments and execute your plan. And don't be scared to go out on limbs when you're designing. It was certain times in this project when me and Jackson we had extra mass, so we added on extra reinforcements like that. That's okay as long as it's helpful. As long as it's helpful to your bridge design, then do it. It's no problem with that. And some changes I would ask for the competition. And I think students should have control of where the loading plate goes. I don't think the flip of the coin was very effective. I think if the students could choose where the loading plate was, then maybe bridges would have held a lot more mass. And I think we should be able to use other adhesive such as epoxy because this will just create stronger bridges, and then everybody's bridges can hold more mass. So yeah, that's my brief video, and goodbye.